Hello, my dear class 7 students. This is video part 3 for chapter number 6, Sound. Following topics will be discussed in this video. Number 1 is the speed of sound, determining the speed of sound in different media, etc. will be discussed. Number 2, reflection of sound when they are falling on a particular area or surface. And number 3, absorption of sound by different substances. Here we will discuss about the speed of sound. Children, if you watch a blacksmith while working, you will notice that the sound produced on striking the hammer will be heard a little later than when the hammer actually strikes. Similarly, you must also have noticed that in the rainy season, the sound of thunder is heard much later than the flash of light is seen. Now from these examples we can say that sound takes some time to travel a certain distance in a medium, and the reason is that light travels much faster than sound. It is understood that it takes nearly a negligible time for light to reach us, while sound takes a much longer time to reach us. Children, here we will see an activity to determine the speed of sound in air. For that, we have to choose two hills, say A and B, which is a kilometer apart. A person will fire a gun from hill A, and another person who is at hill B will start a stopwatch as he sees the flash of the fire and stops it on hearing the sound. Then he will measure the time interval between the seeing of flash and hearing of the sound and let it be t seconds. Then we will measure the distance between the hills A and B and let it be d meters. In the activity, we have already found what is t and what is t. D is a distance between the two hills and T is a time interval between firing of the gun and the hearing of the sound. Okay, so to find the speed of sound V, we have a formula that is distance upon time taken, that is D upon T meter per second. And experimentally it is found that the speed of sound in air is nearly 330 meter per second. Here you have an example to find out the speed of sound in air. So a gun is fired in the air at a distance of 660 meter from a person. He hears the sound of the gun after 2 seconds. So to find out the speed of the sound, so we already saw the formula is distance traveled by the time taken, right? So distance traveled here is 660 meter and time taken by the sound is 2 seconds. So speed of sound is equal to distance traveled by the sound divided by time taken by the sound, that is 660 meter divided by 2 seconds, which is equal to 330 meter per second. So the speed of sound in air is 330 meter per second. It is to be noted that speed of sound is different in different media. Sound travels faster in liquids than in gases. That is, the speed of sound in water is nearly 1500 meter per second, while in air it is nearly 330 meter per second. And sound travels much faster in solids than in liquids or gases. The speed of sound in steel is nearly 5000 meter per second. So children, sound travels fastest in solids and then in liquids and then in gases. You have to remember the speed of sound in different media. Now this is the reason why people living near the railway tracks often press their ears against the track and predict whether a train is coming or not. Why? Because the sound produced by the moving wheels of the train travels much faster through the track than through the air. So just by checking the tracks or pressing the ear near the tracks, they can predict the coming of train or not. Table shows different speed of sound in different media. For solid, the speed of sound is 5000 meter per second. In liquid, it is 1500 meter per second, and in gas, it is 330 meter per second. Children, you have to remember the speed of sound in all the three different media. We have already seen that sound travels faster or fastest in the solid. So here we are having an activity to prove the same. You have to take a long metal rod and keep it on a flat surface such as a table. Bring your ear close to one end of the rod as shown in the figure and ask your friend to gently strike the other end of the rod by a hammer. You will hear the sound two times. First through the metal rod and second through the air. So we can conclude now that sound travels faster through a solid than through air. Children, note that the speed of light in air is 3 into 10 to the power 8 meter per second, while that of sound is nearly 330 meter per second. This is why during a thunderstorm, the lightning is seen first and then a little later the sound of thunder is heard. Children, now we will learn about reflection of sound. When sound strikes a hard surface, it returns back within the same medium like light. The returning of sound after striking a surface is called reflection of sound. The reflection of sound takes place obeying the two laws of reflection. First one is the angle of incidence is equal to the angle of reflection, and the second one is the incident sound, reflected sound and normal are all in one plane. These laws of reflection are same as obeyed by light in reflection. And for reflection of sound, the surface must be of bigger size. It can be smooth or hard. The reflection of sound is used in making the speaking tube, soundboard and trumpet. Let us now see an activity showing reflection of sound waves. So as shown in the figure, you have to take a glass container with a lid and keep a ticking clock inside it. Now you will not be able to hear the ticking sound very clearly when the container is closed. So now you have to slowly lift the lid from one end and you will notice that when the lid is at a particular angle, the sound is heard most distinctly. As shown in the diagram, when the lid is in a particular angle, the sound is heard most distinctly. The reason is that sound is reflected by the lid obeying the laws of reflection which we have already seen. Children, now we will learn about echo. You might have experienced that if you stand closer to a well facing water or at a large distance from the wall of a big empty hall and produce a sharp sound, you will be able to hear two sounds. One is the original sound and the other sound after a fraction of a second. The second sound which is heard after some time is a sound produced after reflecting from the water in the well or from the wall of hall. This second sound is called echo. Echo is a sound heard after reflection from a rigid surface such as a cliff, a hillside, the wall of a building, etc. I repeat, what is echo? Echo is a sound which is heard after reflecting from a rigid surface such as a cliff, a hillside, the wall of a building, etc. To hear echo, the sound after reflection from the rigid surface should reach our ears at least zero point 0.1 second after the original sound is heard. This is because the original sound persists its effect on the ear for about zero point 0.1 second. So if the reflected sound reaches the ear before this interval of time, that is before zero point 0.1 second, it will intermingle with the original sound and it will not be possible for us to distinguish between the two sounds. So what does this mean? This means that little time interval should be there before the reflected sound reaches our ear. We know that the speed of sound in air is nearly 330 meter per second. So in zero point 0.1 second, the sound will travel a distance of 33 meter. Now since sound has to travel an equal distance in going up to the reflecting surface and in coming back from the reflecting surface, therefore it must travel nearly 16.5 meter either way. Thus, to hear the echo clearly in air, the reflecting surface should be at a minimum distance of 16.5 meter from the source of sound. Now, this is a reason why echo is heard in a big hall compared to a smaller hall. The reason is that for hearing the echo clearly in air, the reflecting surface should be at a minimum distance of 16.5 meter from the source of sound. Children, we are already on the last topic of the video, that is absorption of sound. When sound falls on sofa, fluffs and light substances such as clothes, papers, thermocol, coating of plaster of Paris, carpets, etc., these substances absorb the sound to a good extent. Or we can say that these substances are all good absorbers of sound. Our next topic is soundproof box. So what is a soundproof box? A soundproof box means an enclosure such as theater, auditorium, etc., which does not allow the internal sound to come out and the external sound to enter in. So children, you all have visited a theater or an auditorium and you know that the sound there does not allow or it doesn't come out and it doesn't allow the external sound to enter in. So now let us see some measures which can be taken to design such a sound-proof box. So first is the roof of the enclosure must be covered by plaster of Paris after putting the sheets of thermocol. The walls of the enclosure should be covered by wooden strips. The floor must be laid down by thick carpets. The machine parts of all the electrical equipment such as fan, air conditioners, etc. must be placed outside the enclosure. Thick curtains should be used to cover the doors and keep them closed. And thick stripping must be used to cover the openings of doors and windows. Here, children, you might have noticed that all the things which are used, for example, carpets, wooden strips, plaster of Paris, etc., they are all good absorbers of sound. So sound produced will be absorbed by these materials and so it will not allow the internal sound to come out and the external sound to enter in. I hope all of you have understood all the topics discussed in this video. This was the video part 3, that is we have finished our chapter sound. Happy learning children.